Hello everyone, and welcome back to another GIS lecture video. And in this lecture video, what I want to do is I want to move past this sort of abstract idea of the fuzzy membership graph to talk about our first real fuzzy membership function. And so if you remember back to our first video, I said that there were 7 membership functions we're going to talk about. Let's go ahead and start with our first one, which is the linear membership function. So with the linear membership function, the idea is that you either have a high value that you want to consider as highly suitable, or a low value that you want to consider as highly suitable. And that the suitability is going to decrease linearly as you move away from that variable. So what do I mean by that? This is going to be our first fuzzy membership graph. Right, so again, right, our x-axis is the raw data value, and our y-axis is our fuzzy value. Right. So we have our minimum, which is the lowest value, our maximum, which is the highest value, 0, and 1. And so what linear fuzzy membership does is it assumes that the minimum value of the raw data is going to have a fuzzy value of 0. And that the maximum value of the raw data is going to have a fuzzy value of 1. And then what it does is it linearly interpolates, which literally means the graph is a straight line, right? This should be a straight line. Right, a straight line. So, what does that mean? Well, this means a couple of things. This means, first of all, right, that our minimum value of the raw data is going to have 0 fuzzy value. Our maximum value is going to have a 1 fuzzy value. Right, and because everything in between is scaled linearly, right, this is a straight line, that also means that our median raw value right, is going to have a 0.5 fuzzy value. Right. So this is the most basic version of the fuzzy membership function, where we are literally using linear interpolation to set a minimum to 0, maximum to 1, and then interpolate everything in between to a linear function. Okay. So what does this mean from a suitability perspective? What this function means from a suitability perspective is that the maximum raw data value is going to have the highest possible suitability, and that it's going to decrease linearly to the minimum, which is going to be the least suitable. So when you're thinking about generating suitability layers, one of the things that we're going to be thinking about is which suitability function do you want to pick and why. So a linear suitability would work well if you don't know the relationship between how the variable changes and how the suitability changes, right? So you could imagine a scenario where, again, you have a mountain lion that you're trying to model suitability for, and you have the elevation data set. And you know that it prefers higher elevations, but you don't really know how that suitability changes as you decrease in elevation. Linear would just basically say, okay, right, as you decrease elevation, your fuzzy values, right, your suitability is going to decrease linearly as well. Okay. So how can we tweak linear fuzzy membership? Well, what we can do is we can actually change the start point and the stop point for the linear interpolation, right? So we can set, or we can change the minimum and maximum values. Okay, so let's see what that would look like. All right, so we have our minimum and our maximum from the raw data. And then we have our fuzzy membership going from 0 to 1. Right. And so the idea here is by changing the minimum and the maximum values, what we can do is we can define a new set of start and stop points for linear interpolation. So let's say that instead of start setting the linear interpolation to go from the true minimum, we go from maybe 25% of the way, right? So this would be the 25th percentile. Right, so 25% of the way to 75% of the way, right, the 75th percentile. And we make these our new start and stop points. So when we run the software, we say, hey, we don't want to use the true minimum and the true maximum. We want to come in a ways to start and stop early. What this is going to do is this is going to make the 25th percentile a fuzzy membership of 0, and the 75th percentile a fuzzy membership of 1. And linearly interpolate between the two. Right? Everything below the 25th percentile is going to be 0. Everything above the 75th percentile is going to be 1. Right? So what have we done? By changing the minimum and maximum, we've done 2 things. Well, really, we've done 3 things. The first is we've made this transition more steep. Right? We've a faster transition. Right? We're going from 0 to 1 fuzzy values over fewer raw data values. So that transition's happening faster, meaning there's going to be a bigger difference in fuzzy values over the same range than there was in the original data. The other thing we did, right, is everything above the 75th percentile, right, all of these values are now considered considered high suitability, right? And all of these values below the new threshold that we set, right? These are all 0. Right? So we've made more values absolutely unsuitable and we've made more raw data values perfectly suitable. And we've made that transition from not suitable to perfectly suitable faster, right? This slope is greater, meaning that we're changing more quickly, okay? So again, just to recap what we've done here, with linear fuzzy membership function, we set a minimum point, we set a maximum point, we linearly interpolate between the two. If the points that we set aren't the true minimum and the true maximum, anything below our start point are 0, and anything above our endpoint are 1. And so we can create more suitable area and more non-suitable area by moving around these start and end points. Right? And so a good example of where you might want to do this is, imagine, again, thinking back to our mountain line with elevation. Right? Imagine that we knew sort of the point at which it preferred, and we knew that anything above that was great. Anything below that, we wanted to decrease suitability. Right? This is what this would look like. Right? It's increasing in suitability as it's going up in elevation. It hits a point of elevation, and then beyond that, it doesn't care. It's all equally good after that point. Okay? That's how this graph would be interpreted. So as always, if you have any questions, please reach out. Thank you.